Here we go. We have a question, modify the array. So you have given an array and our task is to modify the array in such a way that if the current element and the next element are valid, here valid means they are equal, then we need to double the current number and replace the next number with 0. And we need to do one more thing after the modification. We need to do we need to rearrange the array and place all the zeros on the end. So note here is assume all zeros as invalid and all the other numbers are valid. Then the sequence of the valid numbers is present in the same order, and we do not need to do another modification. We just need to do one modification. So here we have this example. This 2 and 2 is same. This will become 4, this will become 0. So we don't have any valid number. So this 4, then this 4, then this 8. So we have this number and we do not need to do another modification in the array, and all the zeros on the ending side. In this case, this will become, the first element will become 4, this will become 0, this will become 2, then the first element will become 12, here it will become 0. So we have, first we have 4, then we have 2, so 4 2, here we have 12 and we have 8, and all the other are zeros. So let's try to build the approach. So we have, let's suppose we have this example. In this example, one thing to note here is we need to return in a list. So I'm not gonna update the input array itself. So without using without updating the input array, let's try to find how we can solve this question. So here we have this element and its next element is also equal. So what I will do is, we have a list. Let's suppose this is answer. So I will first place 4 here, and this next element will become 0. So one thing we can do is we can add 0, or so I will add two numbers on the go. So this number is valid. I will add first double number and next number as 0. So then I will just skip out this iteration. I will just move to next iteration. So here we have 0, just take the element as it is. Then we have 4, then take it as it is. Then we have 0, then we have 8. We need to do a check, is this number and next number is equal. But in this case, the next I plus 1 number element we cannot access. So we need to careful here. We need to write a condition, is I plus 1 less than n, then only we need to access the next element. So in this case, just take the element as it is. Now it's time to place all the zeros on the right hand side. So for that, what you can do is, we have two options. First, we can take all the non-zero elements 4, 4 and 8 and count the zeros. We have 3 zeros, so just place 3 zeros. But in this, we are doing two iterations. We can do this operation by just using one single iteration. How? So let's find out. First, I will place I here and j also on the same location. So I and j, we have two options. So is I number non-zero? Yes, I number is non-zero, so just to move forward your I is here. So I will be on the 0th location and j will be on non-zero location. So here we have this number, but this iteration is not valid. Why? Because if a starting number is non-zero, this is valid, but we have a non-zero after the 0. This is not valid. We need to do a swap. So j number is placed on a non-zero, but it is before I. Either it start with I or j is greater than I. So if j is less than I, we need to reinitialize our j to I. Is j non-zero? No, j is 0. Is j non-zero? No, j is 0. Is j non-zero? Yes, j is non-zero. So we need to swap the values. We need to swap I and j value. Here it will be 4, here it will be 0. Then again, uh, so is I 0? No. Then I is 0. Is j non-zero? No. Is j non-zero? No. Is j non-zero? Yes, j is non-zero. So we need to do swap. 8 will be here, 0 will be here. 8, then 0. Then is I non-zero? Is I non-zero? Yes, I is non-zero. I will be here. Is j 0? Yes, j is 0. So j will move forward. Now our j reaches n. So we just need to break out. What if we have 1, 2? So what if we have 1, 2 and 3 itself? So I will be here, j will be here. Is I non-zero? Is I non-zero? Yes. Move forward. Is I non-zero? Yes. Move forward. Is I non-zero? No, we cannot access I. So we have one more condition. If I also reaches n, just break out. So let's talk this algorithm on the next test case. So we have this test case. So first, this number is 0, take it as it is. This number is 2 and it is also equal to the next number. Take value 4 and 0. Now we are at this stage, so we just skip this part. We just directly go to the next to next number, next to next iteration. Here just take the number as it is, 0. We have 12. Then in this case number is valid, take 12 means double of the current value and 0 on the same time. So then we have 0, then we have 8. Here I and j on the same location. Whenever our I reaches 0, whenever our I is equal to 0. So here whenever our I is 0, this is valid. This is valid. Means I is 0 and j is non-zero. So we have a 0 before then a non-zero value. So we need to do a swapping. Means if our I is non-zero, that will work. So we want ith value to be 0 and jth value to not equal to 0. I value we want 0. Here I value is 0. This is valid. Is j non-zero? No, j is 0. So just move forward. Now I is 0, j is non-zero. Swap the values. 4 will be here, 0 will be here. Now our I is 0. No, move forward. Our j is 0, j is 0, j is 0. Now swap the values. 2 will be here, 0 will be here. Now our I is not 0. Move forward. J is 0, j is 0, j is 0. Swap the values. 12 will be here, 0 will be here. Next, our ith value we want 0. So I will be here and jth value to be non-zero. So this is 0, this is 0, this is not 0. So swap the values I and j. 8 will be here and 0 will be there. Now we need to check, is I value 0? No. Now I value is 0. Is j non-zero? No. Now j is out of bound. So we have shifted all the non-zeros before all the zeros. So that's how this algorithm will work. Just remember one thing. Our I, our I is less than or equal to j. Whenever j is less than I, we can do j is equal to I. Or what we can do, j is equal to maximum of j and I. Because we want j on the rightmost side. So that's how it will work. Let's try to code this. So we have n, we have array list, we have a for loop, if I plus one element is accessible and it is also equal, so we want to add first double the current value and add 0. So just skip this part, just skip the next part, and it will move to next part. Then if this condition is not true, just take the current value. Then we have filled the values, but we want all the zeros on the right hand side. J is less than n, I is less than n, and I value is non-zero. We want ith value to be 0. So now ith value will be 0 or out of bound. Then we want j on the right hand side. Either j value is equal to I or greater than I. Then if jth value is 0, move forward, we want jth value to be non-zero. If this condition true, just break out. Else we need to set jth value on the ith location, because jth value is non-zero and on the ith value we have 0. So just swap the values and on the jth we place 0. So next return the answer. Let's give it a try and let's talk about time and space complexity. In this case, the time complexity is order of n. We have another order of n. Overall time complexity is order of n. Space complexity is order of n. The code is given in the description box. Thank you all for watching this video.